you are going to understand the concept of unsupervised learning. By the end of this lesson, you will be able to explain the mechanism of unsupervised learning, use different clustering techniques in Python, overview. Unsupervised learning is a machine learning technique used to train the machine learning algorithm using data that is either unclassified or unlabeled and allows the algorithm to act on that data without guidance. Unlabeled data is a designation for pieces of data that have not been tagged with labels identified by characteristics, properties, or classifications. So the flow of unsupervised learning starts with training data that has no labels and depends on the feature vector. The machine learning model defines the predictive model. This is tested with an individual subset of data with its own feature vector. Here, the predictive model defines the likelihood or cluster ID, or a better representation of unlabeled data. Let's look at the difference between unsupervised and supervised learning. Supervised learning technique deals with labeled data where the output data patterns are known to the system. Unsupervised learning works with unlabeled data in which the output is just based on the collection of perceptions. Supervised learning method is less complex. The unsupervised learning method is more complex. Supervised learning conducts offline analysis. Unsupervised learning performs real-time analysis. The outcome of the supervised learning technique is comparatively more accurate and reliable. Unsupervised learning generates moderately acute but reliable results, while classification and regression are the types of problems solved under the supervised learning method. Unsupervised learning includes clustering and associative rule mining problems. Example and application of unsupervised learning. Let's understand unsupervised learning through an example. Consider a scenario where a child had no learning phase and is shown images without the labels. Now, if the child is asked to identify if any range is a bird or an animal, he will lack the information that can help him do so. The best he can do is come up with the following groups based on common patterns, wings and legs, for example. This explains how unsupervised learning works. We show a lot of data to our algorithm and ask it to find patterns in the data by itself. Let's look at the application of unsupervised learning. Unsupervised learning can be used for anomaly detection as well as clustering. To understand clustering, let's look at a simple real-life example. A mother asks her two children to arrange the pieces of playing blocks. The children come up with two different groups as shown with different similarities in the blocks. This is clustering. Each of her children came up with a different type of grouping. One child grouped them based on the shape, whereas the other grouped them based on the color. There is no right or wrong way. Then, how can you pick one set of clusters over the others? This will depend on the similarity measure used by the mother in this case. The arrangement of child 1 is better than child 2 if the similarity measure chosen by the mother was that blocks should have the same shape. However, the arrangement by child 2 is better if the similarity measure chosen by the mother was that blocks should have the same color. Therefore, defining the similarity measure is important when performing clustering. There may be different ways in which data can be arranged in different groups based on size, shape, color, texture, and other complex features. Anomaly detection is a clustering technique used to identify unusual patterns that do not conform to expected behavior. Anomaly detection has many applications in business, such as intrusion detection, system health monitoring, and fraud detection. Clustering. The method of grouping similar entities together is called clustering. The goal of this unsupervised machine learning method is to seek out similarities within the data points and to cluster similar data points together. Need for clustering. Let's look at the need for clustering. Grouping similar entities together helps to merge the attributes of different clusters. In other words, this gives us insight into underlying patterns of different groups. There are a lot of applications of grouping unlabeled data. For example, in order to maximize the revenue, you can identify different groups or clusters of customers and market to each group in a different way. Another example is grouping books together that belong to similar topics. Clustering is needed to determine the intrinsic grouping in a set of unlabeled data, organize data into clusters that show internal structure of the data, partition the data points, understand and extract value from large sets of structured and unstructured data. Types of clustering. There are two types of clustering: hierarchical clustering and partitional clustering. Hierarchical clustering can be agglomerative and divisive, whereas partitional clustering can be k-means and fuzzy c-means. A distinction among different types of clustering is whether the set of clusters is nested or unnested. A partitional clustering is just a division of the set of data objects into non-overlapping sets or clusters such that every data object is in just one subset. A hierarchical clustering is a tree structure that has a set of nested clusters. Hierarchical clustering. The output of hierarchical clustering is a hierarchy. How does the hierarchical clustering form a hierarchy? Assume you are going to create a three-layer hierarchy from 6 different data nodes. So first combine A and B based on similarity and also combine D and E based on similarity. Combination of A and B is combined with C. In the similar way, combination of D and E is combined with F. Now combine C and F inside one cluster. When you look at the final tree, it contains all clusters combined into a single cluster. Let's understand the working of hierarchical clustering. It works in 4 steps. Step 1, assign each item to its own cluster, such that if you have n number of items, you will have n number of clusters. Step 2, merge 2 clusters into a single cluster by finding the closest pair of clusters. Now you will have 1 cluster less. Step 3, compute distances between the new cluster and all old clusters. Step 4, repeat steps 2 and 3 until all items are clustered into a single cluster of size n. Let's understand the distance measure in hierarchical clustering. Let's look at the different kinds of linkage in clustering. Complete linkage clustering. It finds the maximum distance between points belonging to 2 different clusters. Single linkage clustering. It finds the minimum possible distance between points belonging to 2 different clusters. Mean linkage clustering. It finds all possible pairwise distances for points belonging to 2 different clusters and then calculates the average. Centroid linkage clustering. It finds the centroid of each cluster and calculates the distance between them. What is dendrogram? It is a tree diagram frequently used to illustrate the arrangement of the clusters produced by hierarchical clustering. It shows the hierarchical relationship between objects. It is most commonly created as an output of hierarchical clustering. The main use of a dendrogram is to work out the best way to allocate objects to clusters. The dendrogram also shows the hierarchical clustering of 5 observations and the relationship between each of them.